Have you ever wondered whether it would be feasible to set foot on the sun? Although the human race is undoubtedly capable of some incredible feats, let us first point out that since the sun is primarily composed of hydrogen gas and lacks a solid surface, there will never be a landing there. In addition to this, there is the intense radiation, solar wind, and other energy particles coming from our star. Getting people there on a spaceship without it melting, burning, or even exploding would require a lot of technology that we do not currently possess. But that doesn't mean we can't send something near the sun to study it. The Parker Solar Probe is a remarkable device that was constructed with amazing, cutting-edge technology. It is currently speeding towards Venus, where it will begin its orbit with the star. This mission to study the sun will be one of mankind's greatest accomplishments. Scientists have been waiting for over 60 years for technology to advance enough so that we can get a closer look. The mission's main objective is to track the flow of heat and energy through the solar corona and investigate the factors that accelerate solar wind and other energetic particles in the sun. The probe will also study the magnetic fields in the sun. Why the sun's surface temperature is far lower than that of the corona around it is another intriguing question that scientists are trying to answer. Scientists understand that it has something to do with the sun's magnetic field, which connects the sun's surface to its outer atmosphere. It's a key mystery to understanding the sun and solar physics, and with the probe's help, we're about to figure it out. What we do know is that the sun is basically a big hydrogen gas fusion bomb 93 million miles away from Earth with a surface temperature of 5,600 degrees Celsius, which is 4,000 degrees higher than the melting point of steel. That's 7,232 degrees Fahrenheit with a core temperature of 27 million degrees Fahrenheit, and if you weren't just sure how big the sun is, you could fit 1.3 million Earths inside it. It's big, it's hot getting anywhere close to. It has been a serious challenge until now. The Parker Probe, named for Professor Emeritus Eugene Parker, who predicted the existence of solar wind that decades ago, was recently launched on August 12, 2018, and will become the fastest man-made spacecraft ever. It will swoop into the sun's corona quickly and then back out while collecting data over a 7-year period. The probe will fly closer to the sun than any other spacecraft. It will gain the speed it needs using the gravity of Venus during 7 flybys over the course of 7 years that will eventually bring the probe within 4 million miles of the sun's surface on the same distance from the sun as the planet Mercury. Think of this maneuver like a gravity assist or a slingshot around the planet, and each time getting closer to the sun, and it's going to be traveling very fast. For the record, the current fastest spacecraft, defined by its heliocentric velocity, is held by Helios 2, as it was last seen moving away from the Earth at a speed of 1232 miles per hour, but the Parker probe on its final orbit will be hurtling around our star and an astounding 430,000 miles per hour. However, it's currently traveling at 38,000 miles per hour, which is less than 10% of its peak speed, but in the end it will be going so fast that it will leave other spacecraft eating metaphorical dust. The spacecraft is supposed to go into its first orbit with the star on November 2018 and get closer to the sun on 24 different approaches, each one swinging it closer into the sun's atmosphere or the sun's corona. The glowing halo of plasma extends about 5 million miles into outer space around the sun. The probe will have to withstand extreme heat and radiation, but it will zip towards the sun to measure and gather data. It will also have to withstand being bombarded by tiny, fast-moving particles, some of which will hit the spacecraft. To fix this issue, the probe is a little difficult to see unless you're using a coronagraph or looking at the sun during a total solar eclipse. The Parker probe is fitted with Kevlar blankets to protect itself from impacts during its close approach. The sun will appear 25 times wider on the probe than when it left the Earth, and it will also be 625 times brighter. We told you that the Parker probe is moving really fast, but to give you a better idea, I will explain that you probably know that the closer things are in orbit around any object with mass, the faster it needs to travel with respect to the object in order to stay in orbit. If the object is going too slowly, gravity will pull the object towards it, and well, that would be the end of our Parker probe. The Parker Solar Probe will end up reaching speeds of 125 miles per second. The circumference of the Earth is almost 25,000 miles in diameter. This means that if the Parker Probe were in orbit around the Earth, it would make one full trip in just 3.3 minutes. To give you an idea just how close the probe is going to get to the Sun, if our Earth was at one end of a yardstick and the Sun on the other, the Parker Solar Probe will come within 4 inches of the solar surface. You're probably wondering by now how something could survive such a close encounter with the Sun. After all, there are a lot of expensive and sensitive instruments aboard the probe. In order to grasp this, we need to understand the concept of heat versus temperature. We won't give a full lecture because that would take a few hours, but in space, temperature can be thousands of degrees without providing significant heat to a given object. Temperature measures how fast particles are moving, and heat measures the total amount of energy that they transfer from particles. In space might be moving fast with high temperature, but if there are very few of them, they won't transfer much heat energy. We know that space is mostly empty, and with that there are a few particles that can transfer energy to the probe. For example, the Sun's corona has an extremely high temperature but very low density. If you are still confused, think about the difference between putting your hand in hot water versus putting your hand in a hot oven. But please don't try this at home. In the oven, your hand can withstand the hot temperature alloys than in the water, where it's interacting with more particles. Even though the probe will be traveling through space with temperatures of several million degrees, the heat shield's surface only needs to withstand 2,500 degrees Fahrenheit. To put that into perspective, volcanic eruptions can reach temperatures of 1,300 to 2,200 degrees Fahrenheit, which is still extremely hot. The probe needed a shield to protect it from the intense heat and safeguard the instruments of the solar probe. The probe was protected from melting by a shield called the Thermal Protection System, or TPS for short, which is 8 feet in diameter and 4.5 inches thick. The shield is always pointed directly toward the Sun. If there were even the slightest error in judgment, the mission would end in a matter of seconds. However, the spacecraft body will remain comfortably at 85 degrees Fahrenheit, just a few inches past the shield. This special heat shield material was designed by the Johns Hopkins Applied Physics Laboratory and built by a company called Carbon Advanced Technologies. It took 10 years to develop. The material is a carbon composite foam that is sandwiched between 2 carbon plates. On top of the TPS is a layer of aluminum oxide, which reflects light, and a layer of tungsten between the carbon and the aluminum so it doesn't turn gray. This is also a water-powered cooling system. This is the same material that was used as the heat shield tiles for NASA's retired space shuttle. It dissipates heat so fast that you can actually pick up a piece that is glowing hot without burning yourself. But not all the instruments will be behind the TPS shield, and one of those is the Solar Probe Cup, or Faraday Cup, which is a sensor that is designed to measure the ion and electron fluxes and flow angles from solar wind. Unique and cutting-edge technologies were needed to create this thing so it wouldn't melt. It uses sheets of titanium, zirconium, molybdenum with a melting point of about 4,260 degrees Fahrenheit. The tungsten used to make the grids that produce the electric field has a melting point of 6,192 degrees Fahrenheit. Regular wire would simply melt for this instrument. So the team that worked on it grew sapphire crystal tubes to suspend the wiring. The wire itself is made of niobium, and the probe has several other designs to protect it from heat. Solar panels can open and close depending on how close the probe is to the Sun. The solar arrays are shielded by a straightforward cooling system that uses 2 radiators to prevent the coolant from freezing. The Wide Field Imager for the solar probe, or WISPR, is another feature of the probe that will provide the best possible view of the solar wind from inside the Sun's corona. It consists of 2 telescopes. WISPR is located from the field instrument suite between 2 antennae beneath the heat shield. Early in September 2018, WISPR was turned on, and on September 9th, WISPR's door was opened to let the instrument capture the first pictures of the field instrument suite on board the Sun. WISPR then shot closed-door test photographs for calibration. When the mission is over, the Parker Solar Probe will exit in style, much like Cassini did when it entered Saturn's atmosphere or the Magellan satellite became a part of Venus. It will eventually become a part of the object it was sent to study. The Parker Solar Probe will record the size and shape of electric and magnetic fields in the Sun's atmosphere. The mission is named for Dr. Eugene Parker, 91, who hopes to see many of his theories confirmed. Interestingly, this is the first NASA mission named after a living person. We have measured solar wind occurring close to Earth, but only after it had millions of miles to cool down and blur together. The closest approach won't occur until 2024. So until then, there will undoubtedly be many unanswered questions as humanity touches the Sun. We hope you enjoyed this video. Please let us know what you think of the mission to the Sun and what you would like to learn. We appreciate your time.